Hello students, this is a video on the topic test for QA available on the Bodhee Prep Android app. The tests are supposed to help you evaluate your preparation for a concept. So once you've done the basic concepts of a topic, you refer to these tests. There are multiple tests on each topic to understand whether you're able to apply the learned concept in a test or not. Once you have taken the test, you watch the video which gives you the solution for all questions and a brief analysis of what could have been a good attempt for this kind of a test. There are more than 200 topic tests available for Quant on the Bodhee Prep Android app. The link for the app is in the description of the video. Make sure you download the app so that you're able to make the most of these tests. This video is on the topic functions, and this is the test number 5 on the said topic. Overall, the level of difficulty for the test was moderate, and an attempt of net 6 questions correct in this kind of a test would definitely give you a 95 plus sort of a percentile. The ideal attempt time, that is time to go through all the questions and find out those 6 questions for yourself, would be somewhere around the 24-minute mark. If you look at the questions, the first question says, answer the question based on the information given below. F1x is defined as x when x is between 0 and 1. Fx is 1 when x is greater than equal to 1, and otherwise it is 0. So for all values where x is negative, f1x is 0. F2x is f1 of minus x. Now what we can do is we can simply look at values. So for positive value of x will change when the value of x grows from 0 to 1. So I can take the value of x as, say, 0.2 and 4. So these two ranges will be taken care of. The third range for f1x is negative. If you look at f2x refers to minus of f1x, and therefore I will take the same two ranges in the negative side as well. So I'm taking minus 4 and minus 2, minus 0.2. For all of these four values, we can look at the values of f1, f2, f3, and f4. And from there, we will be able to look at the options and see which is the correct option. So if the value of x is such, what will be the value of f1x for each of the value of x, f2x for each of the value of x, f3 of x, and f4 of x is what we are trying to find out. These are the four functions that have been defined. Now f1x for negative values is 0. For a value between 0 and 1, it returns the value of x, so we get 0.2. And for a value greater than 1, it equal to 1, it returns 4. It returns 1, so we get 1. These are the four possible outputs of f1x. What about f2x? When we say f2x or f2 of minus 4, this will be equal to f1 of minus 4, which is plus 4. f1 of 4 is 1, so we'll get a 1 here. Similarly, f2 of minus 0.2 will be f1 of minus 0.2, which will give us f1 of 0.2, which is 0.2. So we get a 0.2 here. When we have f2x positive, when x is positive, f2 0.2, this will become negative value for x in f1. So that we'll get 0 as the answer. And again, here we'll get 0 as the answer for a similar reason. f3x is nothing but negative of f2x. For all x, the value of f3x will be negative of f2x. So we just multiply the corresponding value of f2 by minus 1 to get the outputs of f3x. If you look at f4x and f3x, again, a similar thing that happened with f2 and f1 will happen for f4 and f3. As we can see, the outputs are reversed. 0, 0, 0.21 became 1.200. So here we'll get the reverse outputs, but we can put the value. We can say f4 of minus 4 will be f3 of minus 4, which becomes plus 4. f3 of 4 is 0, so this becomes 0. f4 of minus 0.2 will be f3 of minus 0.2, which is f3 of 0.2, which is again 0. If we look at f4 of 0.2, this will be equal to f3 of minus 0.2. f3 of minus 0.2 is minus 0.2. So we get minus 0.2. And finally, f4 of 4 will be f3 of minus 4. f3 of minus 4 is minus 1, we get minus 1. So we have all the possible outputs of the 4 function. Which of the following is necessarily true? Is f4x is equal to f1x? For these values it is, the other values are negative, so it is not. f1x is equal to minus of f3 of minus x. Let's look at this, just hold on it for a bit. F1 is F1x is equal to F3x. F1 and F3 obviously are not is equal to 0. No, this is also wrong. So B and C are left. Now, if I look at F1x minus of minus F3x, we know that F1x is equal to minus of minus F3x we are looking at. F3 of minus x, F3 of minus x will simply be, since F3x is minus F2x, we can say F3 of minus x will be minus of F3 of minus x, minus of F2 of minus x. F3 of minus x will be the negative of F2x, so minus of F2x, which becomes F2 of minus x, minus minus plus. This is what was given to us initially, that is, they were inverted values and therefore B becomes positive. We can also put the value, if we put F1, if you put x as 4 here, F1 of 4 is 1, minus F1 of minus 4 will also be 1. If you put F1 as 0, x as 0.2, f of 0.2 is 2, minus of F3 of minus 0.2 will also be 2, and so on. And therefore, amongst the following, B becomes correct. We can check for C as well. F2 of minus x is equal to F3x, is equal to F4x. F2 of minus x here will be minus of F3 of minus x. This is given to be F4 of x according to option C. But F4 of x is equal to F3 of minus x. This minus is not there. Hence, option C is correct. This will not is not correct. This will not be equal. Again, putting the values, I think we can get option B. Otherwise, we could have worked like I have done here to get option B as correct. This will always give you the answer. Might take some time, but always give you the answer. And therefore, in terms of level of difficulty, I'm saying moderate. Since I'm making cases, and depending on the condition that needs to be proved, the time taken might be a little higher. So maybe 2.5 to 3 minutes to solve. For three distinct real numbers x, y, z, the function f is defined as minimum of three values, maximum of xy, maximum of yz, maximum of zx. What we can do is we can take x is equal to 1, y is equal to 2, and z is equal to 3, and then see what happens. These functions are defined, we have to find out which of the following expressions indeterminate. A function will be indeterminate invariably when the denominator is 0. So if you look at the denominator here, g of xyz minus g of xyz. G of xyz will return the maximum value of the minimum of three values, and j will return the minimum of three values. So if I put values of xyz here, minimum of 1 and 2 will be 1, minimum of 2 and 3 will be 2, minimum of 1 and 3 will be 1. The maximum out of these three values is 2. If we put the value of 1, 2, 3 in j, we'll get 1, 2 and 1. Minimum of 1 to 1 will be 1. So g xyz minus j xyz will not be equal to 0. So this will be a determinate value. If you look at option B, g of xyz, which is giving me 1, plus h of xyz. H of xyz is max, max, max. So 1 and 2 max will be 2, 1 and 3. 2 and 3 max will be 3, 1 and 3 max will be 3. Max of these three values is 3. So h will return 3 here, minus m. M is maximum xyz, which obviously will be 3, minus 3, and minus n. N is minimum xyz, which will be 1. As you can see in this case, always we will get 1 or the minimum value in of the 3 in j and n, and the maximum value of the 3 in h and m. They will always cancel out and give a 0 in the denominator. So option B becomes indeterminate. The question might look huge or very daunting to start off, but we have to understand the method is straightforward, and all we are looking to do is we are looking to put values in check, and therefore I am saying moderate level of difficulty. Putting values in checking might take some time, and understanding what indeterminate is might take some time. Therefore, 2.5 to 3 minutes to solve the question. F of x plus y is equal to f of x plus f of y over 1 minus fxy. F of k is given as 2 minus root 3. You have to find the value of f of 4k. So obviously, to go from k to 4k, I can add k and k to get 2k, and then add 2k and 2k to get 4k. So first I'm putting x and y as k and k. So I'll get the value of 2k from here, and this will be equal to f of k plus f of k plus 1 minus f of k square. Now, instead of using this value of 2k and then putting 2k plus 2k, let us first solve this. F of k is 2 minus root 3 plus 2 minus root 3, 2 minus root 3 upon 1 minus 2 minus root 3 whole squared. This will be nothing but 4 minus 2 root 3 upon 1 minus 2 square 4 plus 3 minus 4 root 3, taking the square, which becomes 4 minus 2 root 3 upon minus of minus 4 root 3 is 4 root 3. 1 minus 4 plus 3, 7 is minus 6. Now, if we take out 2 common from here, we'll get 2 minus root 3 upon 2 into 2 root 3 minus 3. 2 and 2 gets cancelled. And further, if we take out root 3 common from the denominator, root 3 common from the denominator, we'll get 2 minus root 3 again. So this and this cancels out. And therefore, we can say f of 2k is nothing but 1 by root 3. This is a manageable sort of a term. And therefore, now I put x and y is 2k and 2k. So this becomes f of 4k. And this will be equal to f of 2k plus f of 2k upon 1 minus f of 2k squared. F of 2k into f of 2k. F of 2k is nothing but 1 by root 3 plus 1 by root 3 upon 1 minus 1 by root 3 whole squared, which is nothing but 2 by root 3 upon 1 minus 3, which will come out to 2 by root 3 upon 2 by 3, 1 minus 1 by 3. And therefore, f of 4k will be 2 by root 3 into 3 by 2. 2 and 2 cancel, root 3 cancel. We get the value of root 3, option A. Again, this is, while solving it should not take about more than 2 odd minutes. But this can be a very confusing question if in this step we do not put the value of k. If we look at this value of f of 2k and substitute it here directly, it becomes quite a messy sort of an expression, and then getting an answer becomes difficult. In the xy plane, the area of the region bounded by the graph mod of x plus y plus mod of x minus y is equal to 4 is to be calculated. So I'll draw the graph. From there, calculation of the figure becomes easier. What I'm also doing is I'm drawing two lines, which will be these blue lines. What are these blue lines? These are lines where x is equal to y. So these are lines which are drawn at 45-degree angle. These are lines which are drawn 45-degree angle. Now, the case one that I'm taking is the first quadrant where x and y both are positive. There are two conditions. Either x will be greater than y. Where is x greater than y? On any point on this side of the line in the first quadrant, the value of x will be greater than y. For example, if I take x is 2 here, y is 2. Anything less than this point on this line, y will be a lesser value than 2. So here x is greater than y. In that case, we will open the first bracket as positive. The second value will also be positive. So we will get, because x is greater than y, so x minus y is greater than 0. We'll get 2x is equal to 4 or x is equal to 2. So we get a straight line at x is equal to 2. It is something like this. This is 2. But this will only extend from here to here for now. When x is less than y, in the first quadrant, this will happen in this region to the left of the blue line. Here, the first bracket will be positive because both are positive. The second bracket will be negative because x is greater than y. Therefore, minus y will be the larger term. And from here, we'll get x plus y minus x plus y is equal to 2, or y is equal to 4, or y will come out to 2. So we get a straight line which looks something like this in the first quadrant. So the region bound by this figure in the first quadrant will be this one. Again, this is also 2. If we go on to the second quadrant, case 2, here y is greater than 0, x is less than 0. If x is less than 0, this part will become negative always because this is negative. Minus y by default will be negative. And for x plus y, as long as here on the right side of the blue line, y will be a greater value, so this will be positive. So on the right hand side, we open the first bracket as positive. the second bracket always opens as negative, and therefore we'll get 2y is equal to 4 or y is equal to 2 again. So this line kind of extends here only till this point, that is till it meets the curve. Beyond this point, the first will also be negative, so we'll get minus x minus y. Minus x plus y is equal to 4, so x will be minus 2. So we get a new line which is somewhere here. Continuing like this, you can see whatever we get above the x-axis, we'll get the same form below the x-axis. So we'll get a line here as well. And therefore, net what we get is a square which looks something like this. What is the side of the square? 2 here and 2 here, so 4. And this is also 2 here and 2 here, so 4. So the square will be a 4 by 4 square having an area of 16. For me, this would be almost a difficult question because opening these kind of brackets is a little challenging, or opening these kind of mods is a little challenging. Therefore, 2.5 to 3 minutes easily to solve the question. What we can also do is we can put values one by one for x and y and see where the points are, and from there draw the graph. That will also work out, though it will be a little longer time taking, but we'll get the answer from there as well. A function fx is defined for all real values of x as minimum of the three values minus x square, x minus 20, minus x minus 20. What is the maximum value of fx? Now, if we draw the curves for these three functions, minus x square, x square is positive, minus x square will be negative. So, and will pass through the origin. Something like this. Sorry. Looks really bad, but yeah. Something like this. Minus x square. Symmetrical about the y-axis. Then we look at x minus 20. Now, if I write y is equal to x minus 20, when y is 0, x will be 20. And when x is 0, y will be minus 20. So we can draw a line joining these 2 points, x 20, y 0, and y minus 20, x 0. So this line will look something like this, roughly speaking. This is x minus 20. Then we look at y is equal to minus x minus 20. When y is 0, x will be minus 20. When x is 0, y will be minus 20. Just putting values. So here we have minus 20. We will get a line which looks something like this. The slope of x is negative. Essentially, the points are similar. Now we are looking at the minimum of these three functions. As you can see at the point of intersections, at this for any value which is less than this point of intersection, the lowest value of the three lines will be the curve. And therefore, if I look at the curve for fx, it will trace the x square curve till this point. Then it will trace this line, which is the lowest out of these three. From here, it will again trace the line for minus x minus 20. And from this point, it will again trace the x square curve. So this will be the negative of the three values. We have to find the maximum of this value. The maximum happens here when y is minus 20, x is 0. And therefore, the maximum value of the curve is simply minus 20. What we can also do is, we can simply see the intersection points, because that is where the point will change, or the graph will change from one line to the other. The intersection for these 2 points comes out as x is equal to 0. For that, we see that the maximum value comes out to minus 20. Or the minimum value of these three will be minus 20. That is the maximum value it can take. For every other value, the value of fx will be lesser than minus 20. Again, with the graph, this question should not be very difficult. And since the three graphs are also straightforward, the two are straight lines, one is a quadratic function without any value of b and c. The three graphs are easy to draw. From there, we are just looking at this lower value of the three graphs. Should not be very difficult with the graph. But again, drawing the graph might take 2.5 minutes, which would be enough to answer this question. Should be enough. Fx is given as mod of sin x plus cos x. Which of the following interval best represents the range of fx? Since the options are given, I'll just try to justify the options. Now, they will be maximum when sin x and cos x take the same value. So, when x is 45 degree, I am not very comfortable with trigonometry per se. So I'll just work with the values that I know. I know the values of sine and cos at 0, 30, 45, 60 and 90, number one. Also, I know that the values can be negative, positive. So when we take x is 45, sine 45 plus cos 45 will be 1 by root 2 plus 1 by root 2, which will be 2 by root 2. Hence, the maximum value will come out to root 2. This gets satisfied. 1 is not the maximum value. If I look at positive and negative values when they're of same value but negative sign, for example, if we say if x is equal to 90 plus 45, in this case, sine 90 plus 45 will be cos 45, which will be 1 by root 2. Cos 90 plus 45, because in the second quadrant, cos is negative, we'll have minus sine 45, which will be minus 1 by root. In this case, as you can see, sine plus cos will be 0. And therefore, the minimum possible value is 0. Hence, option D becomes my answer. I am saying easy question because all we had to do is put values and check. Make the values say maximum, make the values inverted sign minimum. And that is my answer. So about a minute to solve the question. For all real numbers x and y, f of x is defined as the positive square root of x plus y if the square root of x plus y is real. That is, x plus y is not a negative value. Otherwise, if it is negative, we will square the value of x plus y. G of x and y is defined as the square of the of x plus y. If x plus y is positive, that is square root of x plus y is real. If it is not real, we take the negative value of x plus y. Which of the following expression yields a positive value for every pair of non-zero real numbers xy? F of xy minus g of xy. So f of xy for every pair. F of xy has to be greater than g of xy if this is it's a positive value. Can this happen? If we take x and y as 16 and 9, 16 plus 9, 25, root is real. In this case, f of xy will give us the root of 16 plus 9, whereas g of xy will give us the square of 16 plus 9. Clearly, g of xy will be greater and this will become negative. In the second case, we are squaring g of xy. So if we put the same values, this will be root, this will be the square. So again, this cannot be always positive. If we look at this case, we are looking at positive value. Positive value. If you look at this case, we would want to maximize fx plus y. If we take a negative value, that is, say x plus y is minus 16 and minus 9. X is minus 16, y is minus 9. In this case, the root will not be real, and therefore gxy plus gxy will return us minus of minus 16 minus 9, which will be 25. Whereas fxy will return us the square of minus 16 and minus 9. And then we are squaring that again because this is xy square. So clearly this will become a very large negative value. The first term is a small positive value, so they will be the difference will be negative. This is not always positive. fxy plus gxy. If x and y both are if the root is real, then fxy will be the positive square root, gxy will be the square. Both will be positive values. If the root is if x plus y root is real, that means fxy is also positive, positive square root of x plus y. Gxy is also positive because x plus y whole square, and therefore this will be positive. If x plus y root is not real, in that case we know that x plus y is negative. Therefore, the root is not real. If you look at fxy, it takes the square of x plus y whole square. So fxy becomes positive the moment you square a negative value. Gxy is the negative of x plus y. So gxy will also be positive because negative of negative is positive. So in option D, whether x plus y is root is real or not, both cases fxy and gxy return positive values. So their sum will also always be positive. Hence option 7 becomes the answer. Again, just taking the values of 16, 9 and then reversing and taking them as minus 16, minus 9 will give us the answer as option D, or we'll be able to eliminate ABC, and that should be good enough for us 2 to 2.5 minutes to solve the question. the domain of the function fx is equal to root of 2 minus 2x minus x square is domain of x. So what happens is the root or the value under the root should always be non-negative, and therefore 2 minus 2x minus x square should be greater than equal to 0. Multiplying by negative value x square plus 2x minus 2 should be less than equal to 0. And therefore, solve for if we solve for x square plus 2x minus 2 is equal to 0, the value of x will be minus 2 plus minus root of 2 square minus of 4 into minus 2, which upon 2, which becomes minus 2 plus minus root of 8 plus 4, 12 upon 2, which is nothing but minus 2 plus minus 12 is 4 root 3. Therefore, 12 is 4 into 3. Therefore, 2 root 3 upon 2. And therefore, the values of x will be the critical points for this inequality: root 3 divided by 2, root 3 minus 1, root 3 minus 1, and root 3, root, no, sorry, root 3 minus 1 when this is positive, and minus root 3 minus 1. So these two will be the critical points for the equation when this is 0. And therefore, for the inequality, since we're looking at negative signs, positive, negative, positive, it will be less than 0 between these 2 points. So x has to lie between minus 1 minus root 3 and minus 1 plus root 3, or root 3 minus 1. Option B. I think this is an easy question. The basic function check for domain is that the under root value should not be negative and the denominator should not be 0. From there, we are just solving an equation. 2 odd minutes to answer the question. F of x minus 4 plus twice of f of 1 by x minus 4 is x cube. We have to find the value of f4, f2. So what we do is first we try to get f2 from here and then from here, and then form equations. So first of all, I am putting x as 6. When x is equal to 6, we will have f of 6 minus 4, which is 2, plus twice of f 1 upon 6 minus 4, which is 1 by 2, is equal to 6 cube, which is 216. Next, I want 1 by x minus 4 to be equal to 2, which means 1 by 2 should be equal to x minus 4. And therefore, x will be nothing but 1 by 2 plus 4, which will be 9 by 2. So if we put x is equal to 9 by 2, we will get 9 by 2 minus 4 is f of 1 by 2 plus 1 upon x minus 4 at x is equal to 9 by 2 will be 2. And therefore, twice of f of 2 is equal to 9 by 2 whole cube, which is 729 by 4. We want to eliminate f1 by 2. So if this is equation 1, this is equation 2. I multiply equation 2 by 2. So 2f1 by 2 plus 4f2 is equal to 729 by 2. 9 cube, this was 8, sorry. 2 cube. So this will be 4. Next, this is suppose equation 3. From equation 3, we subtract equation 1. 4f2 minus f2 is 3f2. 2 1 by f2 minus 2 1 by f2 is 0. 729 by 4 minus 216 by 4. Minus 216, sorry. So 3f2 will be 729 minus 864 upon 4. 864. So 3f2 will be equal to 729 864. So this will be 29 plus 35 is 64. 59, 135 minus 135 by 4. Divide everything by 3. We will get f2 as minus 45 by 4. 135 by 3 is 45, and hence option A becomes the answer. Again, moderate question, easy to moderate, because you would have done such kind of questions while practicing. The only thing is solving might take a bit of time. Option A, 2.5 odd minutes to get the answer. Greatest integer less than or equal to x is the square bracket function. Curly bracket is x is x minus gi of x. Now any integer x or any real number x can be written as integral plus the fractional part. greatest integer function will return the integral part. And therefore, curly x will return us integral x plus fraction minus integral, which is the fraction part. For example, when I say x is equal to 3.4, square bracket x will return us 3. This is the integral part. And curly bracket x will return us 0.4, the fractional part. If I say x is equal to minus 3.4, square bracket x will return us minus 4, and curly bracket x will return us 0.6, integral plus the fractional part. Fractional part would be positive. For example, from here, if I put minus 3.4 minus of minus 4, we'll get 0.6. So this is what the values are. We have to find out the real values of x satisfying 5 GIF x plus 3 curly bracket x plus is equal to 6 plus x. Now, if I write this, we can say that from here we'll get 5 into integral part of the real number plus 3 into fractional part. This is 6 plus integral plus fractional part. So 5i minus I becomes 4i. 3f minus f becomes 2f is equal to 6. Divide by 2. 2i plus f is equal to 3. Now, clearly, this is an integer. This is an integer. And therefore, the only possibility for f to have a value is when it is an integer, which will be 0. Otherwise, if you have any other value for f, it will not be, the equation will not be satisfied. And therefore, f has to take a value which is 0, which means 5 into x integral part is equal to 6 plus x, which means 4x is equal to 6, which is x is equal to 1.5. Here the integral part is not 0, so this is also not a solution. Hence, no solution is possible, or 0 becomes my answer. Again, I would call it a difficult question even after answering. I'm not sure if the answer is correct or not. But again, to do this, it should take about 2 to 2.5 minutes. If we look at the overall test, moderate to maybe difficult level of test, 6 questions net to be attempted, 21 to 24 minutes to do them. The questions that I would choose for my 6 questions would be 2, 5, 6, 7, 8, 9. Which are these? I am not counting this as a question that I would attempt, because sometimes we get confused with x and do not take the values, and therefore not counting this. The second question I am counting, because all you have to do is take x as y z is 1, 2, 3, and the answer will happen. Might take time, but we'll get the answer. Not counting this because it is easy to get confused with k, 2k, and 4k and when to put the value. This again I'm not counting because drawing the graph might be a little difficult. Definitely counting the standard procedure, draw the graph, look at the maximum point, putting the value of x. So I'm counting this as well. Counting this as well because the options were easy. This again is a standard format of the question, should always be attempted. Because we've done similar questions earlier, therefore I'm counting this question as an attempt question for me. This I'm not counting, even if I'm correct, I'll not be sure that I've done this question. And therefore, for me, the 6 questions will be 2, 5, 6, 7, 8, and 9.